Okej. Det är grönt.
Ja. Jag räknar ner.
Ja. Ja. Right. So today, sorry, I have to switch this now. Today we will then look at one old exam, and you can ask questions about anything, and either on Slack or in here. And well, we can start with if there are any questions before we start looking at one of exams. If we look at how the exam is, it's similar to previous year, just a little bit of change. There are a bit more but smaller questions, I would say. So there are still 8 questions, I think, yeah? Yeah, but each question some of them have more sub-questions that are smaller, but otherwise it's the same structure. And it still sums up to 80 credits, right? Yeah. So 80 credits, and you need to pass 50 credits, 50% to pass.
Så 40.
Yep. And where do we have them?
Almost at the bottom.
It's at the bottom.
What about
Right.
the grade distribution? So I think I've seen you mentioned previously that you distributed the grades based on a scale. So is that like changing every single change based on like?
Well, the grades for the exam then is, I mean, 40. If you have 40 credits, you just get an E, and then it's just evenly distributed from E to A, above 40.
So there are not like special distributions, just like.
No, it's a flat distribution there. But then the final grade is a combination of the exam and the practical work. So the practical work can affect the end result. So if we first grade the practical work, these 4 together to get 1 grade for them, and then we weigh them together with the exam as well. So it counts. Yep.
Will there be coding in the exam?
Well, there could be some type of pseudocoding that you need to define some type in pseudocode, but you don't have to write real programs during the exam. I think we've seen a few examples of that before, but
Last year, all the exams had it. That's why I was asking.
yeah. So pseudocode, yes, but not. You don't have to have exact code. If you require that, we would need to allow you to have some material with you. Otherwise, it wouldn't be fair. Let's see, what do we have here? Here we have 15, and that one was 14. Yeah, which one should we take? Do you have any preferences for which exam we should look at? I mean, the one with suggested solutions might not be the best one because we already have solutions there. So, what are the other ones?
Can we do 2014, 03, 21?
Yep, we can do that one. Which have some marked out. So now I will leave over to Morgan then, who has the first questions.
Okay. So I mean, in some of the questions are strange, and I will mark that, and then you can assume that there will not be such questions, because some of them I can't remember. So for example, B here it's a bit strange to me. I will try to give you an answer, but it's very hard to say what is a perfect answer. So maybe Ola will have to jump in, because I think, was this one of yours or?
Yeah, maybe.
Yeah.
It's more of a reasoning, really.
Yeah. But anyway, if we start from the top, and if we start with the A one, and what you notice here, but this is not something we do anymore. You have the Swedish and the English. Now it's just English. So because it seemed wasteful to have the Swedish version as well. Anyway, so we talk about the development of internet over time and the ratio of UDP versus TCP traffic. And I mean, this is, like Ola said, this is a reasoning question. So if I were to grade this today, I would not give wrong for, if you just say TCP, no explanation, or UDP, no explanation, then it's a bad answer. But if you were to say UDP and you could provide me with a good, decent answer for why you think that's the case, then I would at least try to understand how you're thinking. But what I would say here is that TCP is dominant at the moment, because when you look at some of the larger protocols that you would use, like HTTP, and if you look at most of the streaming services, they generally use HTTP as their sort of transport part. And many of the apps that we use also use TCP as their transport. So in many cases, you have HTTP as the sort of the dominant protocol for many services, even though you might think that something like music streaming, it could be something else. They are generally based on HTTP or something similar. So I would say that TCP is dominant today. This can change because, as we talked about, UDP is, or HTTP is moving to UDP in the future. So maybe we'll see a shift here. But at the moment, I would say TCP is the most dominant. Which applications generates most of the traffic? I mean, I would say that web browsing here is what would do it. But again, if you have some good reasoning, then that could at least give you credits. If you were to say here that TFTP generates most of the traffic and that's UDP, then that would of course be stupid and incorrect. But if you would say, no, I think that BitTorrent, for example, would be a majority of the traffic, then, or Netflix streaming would be a majority of the traffic, and then you would reason about it, then we can see. So it helps to write how you think when you answer questions, unless there is an obvious answer. So if I say, what is the size of an IP address? Then you can't say, oh, I think it's 15 bits and here is why, because there is a correct answer. But if it's something like this, it helps to write something that explains how you're thinking. And the number of sort of distributed IPv4 addresses, as we've said many times, all the addresses have been used. So we have now distributed all of them. And in the early 70s, where we talked about class-based addressing, there were giving out addresses in large chunks, but they were not used. So you started to hand out big series, and the amount of IP addresses you can get if you ask for them today has become a lot smaller. So you might, if you're happy, to get a C-class block. But early on, you could get A-class blocks. And then people were just sitting on them. So it's also hard to say that the distributed addresses versus the actually used addresses. But there has, of course, been an explosion in how many addresses are actually used. So what I would say is that, I mean, there has been an explosion in the number of distributed addresses, but also the ones used. But for questions like this, try to reason, and list. You can see that it's 4 points. So 4 points means that you're expected to write a bit more. If this was a 1 point question, then you could get away with being sort of on a superficial level. But if it's 4 points, that means that we want some kind of details here. And like Ola said, I think we moved away, so there will be more questions with fewer points. So I think that most of the ones that I did had something between 4 and 5 sub-questions with like 2-3 points each. And then you don't have to be as detailed. But if it says explain how, I don't know, Dijkstra's shortest path works and you get 10 points, then you can't just write, here is the algorithm and then be done with it. Because for 10 points, you need to be really detailed. So who is driving the evolution of internet today? Who are developing the underlying technology and the different services available? And I don't have a good answer for this question. So if I were given this question, I would try to come up with some BS answer where I tried to formulate something. But I mean, the big internet companies are driving the services today. So places like Google, Facebook, etc. They are driving the services, but they're also driving networking, the protocols, how they are used. So for example, if we look at something like the web standards today, they're almost dominated by the big companies like Google, Apple, Facebook, who try to define how the protocols work, what they do, which features they have. And that is also the big push for going to, for example, UDP for HTTP 3, because there you have more power to change the protocol. It's quite hard to change how TCP works. But if you move away from TCP and you start to use UDP, you're allowed to have much more power on how you would define it. So I would say it's the big companies that are driving internet today, but we're also limited in what we can actually change for the network to work. As you, yeah.
Också driver på. Till exempel att vanliga företag som kanske inte har med datorer att göra egentligen driver på utvecklingen att de implementerar i kylskåp, lastbilar, allt möjligt annat.
Yeah, so the question was whether ordinary non-IT companies like Volvo or Electrolux, for example, are also pushing the development. And I would say that this goes back to the question here that most of the services we get use HTTP and some kind of web technology as their underlying software. So if you go, for example, to one of these kiosks where you order stuff at the restaurant, for example, it's often web-based. So it's based on HTTP and a web page. You just have a different interface to it. And the same thing goes for many of the applications you use on your phone. I don't dare to say whether Spotify is HTTP based or not, but I would be surprised if at least some of the music streaming things are not HTTP in sort of the bottom layers. Because all of the other more fancy protocols there are so many difficulties with firewalls and all of the stuff you have on the internet. And that's why going for HTTP is kind of safe, because you know that it will get through all the firewalls because no one dares to block web traffic. But since this is a 4-point question, I would also like to see some reasoning here about why you think that is the case. So try to give some examples of, if you can think of something that you've read about how some things are being developed by these companies. Ola is strange. So, if we move on, ICMP, this is, as we talked about, sort of the debugging and information protocol of the web. Or sorry, the internet, sorry. I was stuck in the previous question. So the basic point here is to have some kind of information and debugging protocol that you can use. And one of the more common uses that we've talked about is ping, that uses ICMP. And you use that to test connectivity between two devices. So you can see if there is actually a network connection between them. We also talked about traceroute, which was also one of these debugging tools that you can use to check which path a tool takes. And that's also generally implemented on top of ICMP. What are some of the different messages that can be sent using ICMP? Well, we talked about ping. We have the ping and the echo, which is the ping, and the echo reply, which is what you get back when you send a ping. You have this timeout exceeded, which you get when you get too many, when the TTL reaches 0. I think at least it's called, it's not called timeout exceeded, right? It's something similar to that, but I keep screwing it up. Anyone that can think of a fourth?
Host unreachable.
Host unreachable would be one. there are a bunch of messages, but there are not that many. I think it's something like 8 or...
I think there are more, but
Yeah. Yeah, yeah. So here, 4 is probably a reasonable amount. So you should be able to name 4 types of messages here. But more than that, we will not ask for 6 or 7 different types of ICMP. 4 is probably pushing how many we would expect you to know. And then we talk about traceroute and how that uses ICMP. And we've talked about this multiple times. I will just give you a brief overview. There's even a video on that. But the idea that traceroute uses is this time to live. Because whenever time to live reaches 0, the router will send a message back saying that this time exceeded message. And what you can do is see who sent that message to you, and you know that that is the point where the time to live reached 0. So if you start by sending a message with time to live 0, then the first router will fail and send you back a message, because then it will be 0. And then you will just keep sending it with 1, 2, 3, 4, 5, 6 and increment it. And then the idea is that every step of the path will send a message back to you when it reaches 0. So for the first router, start with 1, it gets to 0, and you get a message back. For the second router, you start with 2. The first one decrements it to 1, and the second to 0, and then you get a message back from the second router, and so on and so forth. So it's just clever use of the time to live field and getting them to reply with ICMP messages. Any questions about this, or everyone is happy with the answers? We talk about standard services on the application level, or standard application level protocols. I really don't understand why you're not allowed to mention SMTP here, but maybe there's a question relating to that somewhere else on the exam. Yeah. But since we don't talk about SMTP, which is the mail protocol, much in the exam, in the course, that doesn't really matter too much. But what we talked about here on the application level is, of course, HTTP for the web. We talked about FTP for file transfer. And then we didn't really talk much about standard application protocols. But I mean, I'm sure you can think of stuff that you use. So for example, SMTP, we use that to send mail. We use IMAP to fetch mail. So IMAP is another of these standard protocols. And if we want to stay in the mail field, we could, of course, talk about POP, which is another one. We could talk about DNS here, which would also be a standard protocol on this level. So basically anything that you can think of. HTTP, yes. I said that, right? Didn't I start with HTTP? Yes, before FTP. Yeah. No, I was just, because that's the obvious one. I was so sure I said it, so I thought, please don't say I said something like web, or because that's not the standard protocol. So there are a bunch of them here, and in one of the slides you have a picture showing a bunch of protocols. You could say secure shell, you could say telnet, you could say whatever you want, as long as it's one of these application level protocols. For 4 questions, since we ask for 4 of them, it's sufficient to just name them. But if you pick something that is super rare, you should write out what it means. So if you should just not try to generate random letters with a TP at the end. So it's like the XZ TP and say, yes, it exists. If you do that, try to write out what it is. But otherwise, if you just write FTP, then that should be fine. Yeah.
Should we explain what it does also, or naming?
For 4 points, 4 protocols, I would say that naming is sufficient. If it was 2 protocols, 4 points, then I would expect you to write a small part. But then I would also say, write something about what they do. So try to read. In many cases, people lose points because they don't read the question properly. So here it says, mention 4 of the protocols besides SMTP. If it would have been mentioned and explained their purpose, then you would have to write something about what they do. There are 2 transport layer protocols. Here you have describe them briefly and mention why there are several protocols to choose from. So there are two transport protocols. One of them is named in TCP and IP, and that is of course the TCP transfer control protocol. And then we have UDP, which is the datagram protocol. So these are the two ones we have to pick from. The main difference is, of course, one of them is reliable, connection-oriented, and the other is unreliable and connectionless. You can here write some of the other properties that they have. Again, this is a 6-point question, so there you would need to write slightly more than just mention what they're called, and to say that one of them is connection-oriented and the other is not, that would not be sufficient for 6 points. But maybe 2 or 3 of the properties. And then you should also talk about why there are several protocols, and that could of course be worth 1 or 2 points. And what you would say here is that, I mean, different applications have different needs. And that is the main reason. We talked about how TCP adds complexity and overhead, and not all applications needs that. The most common example that we talked about is UDP, DNS, which is a very simple request-reply protocol. And there you don't need the setup that TCP requires. While for other things like web, where you transfer large images, then you need this congestion control and the performance and all of that, the safety and reliability that you get, reliability, not safety, that you get from TCP. Speed, yes. So, I mean, on a local network, UDP can be faster than TCP because you can just start spamming at all kinds of protocols immediately, while with TCP you have to negotiate and build up the window size, set the congestion window and all of that. So for certain things, UDP can be more efficient. For others, it's not as efficient. So if you go within the local network, for example, UDP can be very nice. If you go over the internet, there's a higher risk of losing packages or package drops and stuff like that. So not all have the same requirement. It says transport layer here. So since it's a transport here, we don't want other things that are on top of IP that are not transport level protocols. We talk about multiplexing and inverse multiplexing or demultiplexing. And the idea here is, in this case, when we talk about it on transport level, is the port numbers. So we use port numbers to allow multiple services to run over a single computer. Because remember that on IP level, we only are concerned about communicating between different computers on the network. So in order for transport streams to be able to reach different services, we need the port numbers. And that is where we take multiple different services and send them across the same network. So we are multiplexing and demultiplexing these into the same channel, but they are split on the local machine, and they are sort of compressed on the sender, split on the receiver into the port numbers, so that you can have a single computer communicating with different services on the remote server and the other way around. So you use these to be able to split between them.
Can we draw pictures to prove
I think Ola can draw a picture here. I don't know if they can see it.
on the example?
Yeah, of course. It's generally a good idea to draw pictures, because some of these are difficult to explain and they're super simple to draw a picture of. But remember that when you draw a picture, explain things in the picture. Don't just draw it and say, this is it. Write some text to illustrate the picture.
Multiplexing, inverse multiplexing on link layer.
Yep.
So here you have several streams sharing the same physical channel. That's multiplexing. Here you have one physical channel split up in several physical channels. We can combine the bandwidth of several physical links, and then so they get higher speed in total from end to end. So this is inverse multiplexing. But of course, if this is multiplexing, this is demultiplexing. So
Yeah. Yeah, so here the confusing thing is that I don't know what you meant with, because when I read transport level here, I read that as transport layer, and there you only have the ports as the multiplexing.
Yeah. That I also mentioned on other layers. So.
Oh, I maybe missed that. Yeah. But that also shows that if you're unsure about something, feel free to make assumption, write down the assumptions. If the assumptions are totally incorrect, you will still get 0 points. But if they are reasonable and make somewhat sense, then you will at least get some points. We talked about bridges to connect different network segments. And again, a 6-point question, 3 different things. So that means that you should have some kind of explanation of what these things do. So we talked about this self-learning and distributed spanning tree. We didn't really mention adaptive frame filtering here, but I would assume that you mean these connected to self-learning. Yeah. So the idea here, as you might remember, is that if we start with the simplest case, we have a repeater that just sends the signals. And we get all the noise between the different networks when we connect them via a repeater. With a bridge, we can do it smarter. So with a bridge, we, instead of just propagating the signal, we propagate frames. And what we can do with the frames is only send frames that are needed to be sent to that network. So if you think back to a switch, for example, which we talked about, which uses some of the same principles as a bridge, we don't send traffic to a port that the traffic doesn't need to go to. So if we have 3 ports and we know that the computer is on one of the ports, we only send traffic on the port that the computer is on, because otherwise we would just spam it to other parts of the network where it doesn't belong, and then we would increase the load on that network. So the idea here is that if we look at Ola's pictures, I mean, it doesn't really help much, so if you cannot see it remotely, don't worry too much. But the idea is that if traffic should go to here, it makes no sense to send it on the other 2 channels, because it will not be received by anyone there. So this adaptive frame filtering means that we simply decide which frames to pass onto one of the ports of the bridges and which not to pass onto that port. So then you might wonder, how do we figure that out? Well, we could of course manually configure it, but it becomes much more useful if we apply self-learning. So what the bridge does is it listens to traffic that originates from a port and tries to learn which computers, which machines are in that direction, are connected on that port. So by learning and listening to which MAC addresses, which hardware addresses that passes through from that port, we can figure out that those machines are on that port, so I should send traffic on that port to those machines. And if I haven't received them from that end, then either I've never seen the computer before or I know it to be on a different port. And if I haven't seen it before, then I need to send it on all ports because I don't know where it is. And then we have the distributed spanning tree, and the distributed spanning tree comes in when we want to avoid to have loops. Because when we just connect bridges, we can easily create cycles or loops in the network. And we don't want those, because then we will just forward traffic in a loop, and then we will send it all over the place, and we will increase the load on the networks. So distributed spanning tree computes, it takes the graph and computes a tree that represents the graph, and that tree does not contain any loops, so it's free of cycles, because a tree can never have cycles. That's one of the differences between a graph and a tree, and the bridges form a graph. So we take the graph, compute the spanning tree, and that spanning tree is guaranteed to be free from cycles, free from loops, and this will mean that only some of the ports of bridges are turned on or turned off. There is a big algorithm to do that, and you don't need to sort of formulate the algorithm here. What you should do in a question like this is not only explain spanning tree, but also distributed. And what's distributed in this aspect is that all the nodes compute it as a distributed process. So each bridge takes part in the computation of the spanning tree. So it's not computed centrally and distributed to the bridges. Each bridge is part of it using this distributed algorithm, but you don't need to explain the algorithm here to get 2 points. Just what it is. And then we have routers. And I think this is Ola's question, actually. So should I look if there's one more of mine, and then we can move back?
There we can move back.
Yeah. So we talk about two types of addresses, logical and physical, and this is the IP address and the hardware address. We usually call it an Ethernet address or a MAC address here. But what we talked about is that all network devices have some kind of physical address that is hard-coded to that network adapter, network card, and that can never change, and it is dependent on the machine. The IP address, on the other hand, is dependent on the network, so that will change whenever you connect to a different network. And that's why we call it a logic address, because it's the address the computer has when it's part of this network. So if you bring your device to university, you will get one address. If you bring it home, you will get a different address. But you will retain the same physical address, because you're generally not changing that. Why do you need these? Well, you need the IP address to be able to communicate across networks. Because as you might remember when we talked about, and what Ola will talk about later about the routing tables, is that if we needed to keep track of all the machines on the network, where they are, which network they're part of, and have routing tables that contains all the addresses of the different machines, then the routing tables would explode in size, and it would also be very difficult to transport that information across different routers. So what they do is they deal with networks, and then any machine that's part of the network is part of the network. And to find that machine, you just need to find the actual network. So you send traffic towards the network, and when it arrives at the local network, you use the physical address to actually find the actual machine. So when you communicate inside the network, you use the physical addresses. Between the networks, you use the logical addresses. And one of them is part of the network layer, and the other is part of the link layer. So one of them is part of Ethernet standard, and the other is part of the IP standard. What else did we have here? You use names instead of addresses for computers. Where and when is this translation? Well, the protocol used is DNS, the domain name system, to be able to translate between these two addresses. What else did we talk about? It happens generally at your local DNS server. So a machine has a DNS server configured, and whenever you need to resolve between an address and an IP address and a physical name, you do that via your local machine. You can have a cache on your local computer that stores it. You have a cache at the DNS server, but generally the translation happens at your local DNS server. Yes, or a public that you choose. So you can configure whichever one you want. You might be using one of the Google's ones, 4444, or some other that are available, or you pick the one that you are assigned from here. There are pros and cons about using either. Generally, you get better speed if you use the local one because that's closer to you, so you have a shorter distance to travel. And you might not be able to use all these geo services if you use some of the others. But sometimes addresses get blocked, and then it might help to switch to a different DNS because maybe that doesn't block those addresses. Did I miss one part of this? No, I think that was good. And this is also a 6-point question. Or this is a 6-point question. The first one was a 4-point. So you would need to provide some detail about where it's done, but you don't need to explain how the protocol works, what the packages looks like, what classes of addresses there are, and stuff like that. But that comes in the next question where we talked about, yeah.
For the DNS, do you have to explain like the whole system, like the root server, the authoritative name server, and the TLS? Like
I would not require it for this question. So here you would only need to know that you have a DNS server that your computer talks to, and that is part. And then if you mention that it's connected to the root server, and if you talk about that as well, that's better, of course, but it would not be required for this question if I graded it at least. So try to answer sort of as much as you need, but not more and not less. So we want like the exact answers.
But there could of course be a question about how does a recursive DNS work, or what type of DNS records are there. So
Yeah,
there could
yeah.
be deeper questions, but not for this one.
Yeah. No. And it's of course useful to know these things, because as you look back to questions, there tend to be questions about DNS and things like types of records, iterative, recursive, and so on and so forth. Address classes. So we have the ABC, and these are just sizes of networks. And then you have the multicast, which is when we send to several recipients. So we are able to send a single message to multiple recipients. We haven't really talked too much about multicast. We just mentioned what it is. Okay, you have. Yep. Then I will leave if you want to add something to the question here. Did you talk about reserved as well? Because we haven't really talked about those.
Reserved.
The reserved class. No.
That's not used as far as I know.
No, exactly. So there is a reserved class, but we don't really use that. So what I will focus on in this question is the A, B, and C classes, and those are just size classes, because when we started, we talked about how routing was done on network level, or IP is used to communicate between networks. And early on, these were the ways you decided how large is a network. So what is the network part? What is the host part? And A was the largest, C is the smallest, and they simply decide whether you have 24, 16, or 8 bits for the host part and the opposite for the network part. So A has very few networks, but several machines in the networks, while C is the other way around. Does anyone remember how you differ between the classes in an address? Yep.
The first, if it starts with 0, it is A. If it's 1, 0, it is B. And if it's 1, 1, 0, it's class C.
Exactly. So the first 3 bits, or the first 1 to 3 bits of the address decides which class it is. So you can always figure out by looking at it which class it is. And since you know that, you can look at since you have these, the bits, you will know that if you start with a 0, then there is a maximum limit. So you have to be 127 and below. So 10.1. something is an A-class network, for example. While since we are mainly on 194, that is a C-class address. And you can figure that out by just looking at the bit pattern. Which one of these is generally used today? And how come the others are not used? Well, I would argue that C-class is the ones that are mainly used today, because there are simply not addresses available in the others. You could argue that maybe B-class is the one that is most typically used, because the problem with C-class is that you have so few actual addresses for computers that it's hard to squeeze them in. So for many networks, you would actually need a B-class, but it turns out that you only have about 65,000 B-class addresses, and you quickly run out of them.
Part of it is also that you're using classless.
Yes.
So it's not really A, B, and C classes anymore.
No.
You have the size of it. That's
Yeah. Yeah.
So you have a net mask where you use classless CLDR notation.
Yeah.
Dynamic.
Sorry?
Dynamic.
Yep.
So
Yeah.
if anything, could it be argued that multicast is used because ABC is deprecated and reserved is not used? So
Yep, you can
Yeah.
target for multiples
Yeah.
as well.
Yeah. So here, this shows why it's important to actually write a motivation, because like reserved would probably not be a good answer that we would accept, but the other ones, as long as you argue for it, A would be quite hard to argue for, because there are so few of them, and people are starting to release addresses from A-class. But it shows again why it is so important. So I think that it's now Ola's turn. Yes. There were.
Okay, so routing. Let's see here.
I think it was it 4 or
No, no,
6?
6. Yeah. So, in the question we already handled bridge, but now we're talking about route events. Briefly describe 3 of these protocols, and you get 6 credits from, so 2 credits for each protocol. And I mean, the obvious protocols to choose here are the one that we mainly talked about, which are what?
Static.
No, that's not a routing protocol.
RIP,
RIP, yeah,
P,
OSPF,
OSPF.
and BGP. I mean, those are the 3 that we talked mostly about. We mentioned a few others as well. And to get the full credit here, you would need to describe at least, okay, that BGP is the one that is used for routing on the internet between autonomous systems, and that it doesn't have a metric, it just finds a path among a system. And then within autonomous system, we can use, for instance, RIP or OSPF or any of other, there are a number of others. And then that RIP is a distance vector protocol, and OSPF is a link state protocol that can handle bigger networks. And I mean, something like that would probably be enough to get the full credit here. And then we talk about a routing table. What type of information do you typically have in a routing table? Well, the purpose of a routing table is to know where we should forward something that we don't know how to handle. So we need to know about an address that we want to be able to reach. So that's the first part. A packet coming in, we need to match it against the first column in routing table. Where should this go? We need to find a matching entry here. Once we find that matching entry based on the network part, we look in the next hop. Where should we send it? So that's on what other known router do we know that we can send it to? Or is it possibly in the local network? And then we typically also have some type of cost. How far is it away to that network that we're going to? If we send it to that other router, how many steps will it take in order to get there? Depending on what type of metric we're using, but the cost of using that link, which opened up for this possibility that we can actually have several entities for the same network but with different metrics, and then we can have maybe multipath routing, or if one fails, we have a secondary router. So there are options of that. But those are typically the 3 entries we have. The network and destination address. Sometimes we divide that into address and mask, next hop, and the metric. So for 4 credits, that is enough to describe that actually. So, right, so that was everything from that exam. Let's see if we have something on the Slack. No, we don't have any questions on Slack here, as far as I can see. So, any other questions here then? Yes.
Could we see some questions about the quality of service, like some later lectures?
Yeah, let's see, do we have that in any of the new ones? I haven't checked them this year actually. Oh, I have to download them.
Last year's exam was around here, I guess.
Oops. Man.
Anything that has appeared on any of the lectures, unless we've said this will not be included, can be included. And if it's in the reading instructions, then it can definitely...
I mean, here we have a little bit on quality, so we talk about delay and throughput as parameters on network. Jitter is connected, but it's more on quality, perhaps on network, what we want to measure. So it's not exactly quality of service. A network should have some general properties briefly, reliable, fair, efficient. No, that's also related to quality of service, but not exactly. Multicast routing, no. MIME, ADSL, network programming, no, nothing here either. Twisted pair, CRC, stop and go. No. But I mean, typically what could come up are ideas about, I mean, first we have a big division between if it's coarse or fine-grained quality of service. And then depending on which one, we have different type of protocols. If we just look at classes of traffic and try to, on a coarse level, prioritize some traffic over other, or if I have a fine grain where we are looking at each flow and actually trying to give a network gives okay, so yes, I can handle this flow. I can give you 10 megabits per second with maximum delay 5 milliseconds for the entire transfer. And then each packet has to follow that flow. Each router have to have negotiating. So that's the fine grain. So we have the int-serve and the diff-serve protocols, for instance, to handle coarse and fine grain. So that's the type of question that could come around quality of service. Anything else? Exam is on Friday, right? And you have been distributed in many different rooms. Have you got the exact location for each of you? Yeah. I think it was 4 or 5 different rooms here in Växjö that you were divided on.
Not this morning though.
Sorry?
Not this morning for our electronics exam though. Everybody was in Stenladen. So.
Yeah, but they say that Stenladen is okay because it's so much space between the tables, so I think that is actually good. But normal rooms, then you need to spread out the students more in this situation, so that's why we use more rooms when we have smaller rooms. Yeah, it's something someone else is deciding, so we don't really have a say about it.
I think they want about 2 meters between people, because you should not be able to sneeze 2 meters.
It doesn't matter if someone has it, then everyone will catch it because it's respiratory, so it'll spread through respiration.
It's drip-based, so you need to be hit and get that into you.
According to an expert, it's respiratory, so...
Okay.
Like, for example, in Boston, there was a conference, there was about 100 people, one person had the coronavirus, and then afterwards everyone got it, so it's just a respiration, you just have to be in the same room.
Okay, because here we've had cases where it doesn't spread like that. So
Okay, we actually got a question here on Slack. Why are some questions removed? And that is because we actually change the course a little bit, the content of the course. So the questions that we looked at that were stroken out with red doesn't apply for this for this version of the course. So you don't need to know about those things. That's why they were stroked out. Yes?
Well, there, if there is a question about the newer technologies, like the last lecture I think it was,
Yeah.
what kind of questions would there, like, would you just ask the newer
Well,
technologies? Like,
if you've seen the lecture about this new technology, you saw that it was on a quite abstract level. We just talked about them. What are they? What does that mean? Why are they interesting? And so on. So it would, I mean, the question would be on the same level, just talking about why is this an interesting area and what is it about. So no details about the protocols, for instance. I think the only protocol that we really looked a little bit more in detail is the Zigbee protocol. There we talked about some details, but otherwise it's very little detail. Yeah. Someone is typing on the Slack. We'll see if we get another question here. Okay, the lecture without sound. Yeah, yes, it is relevant. You will just have to look at the slides and read on the book more for that lecture. If I have time, I will put up a short resume and make a video of it this week, but don't count on it. Read the book. That room is not working anymore with streaming for some reason. Okay.
So we should just add that there will be a visit during the exam. In Växjö, not in Kalmar, of course. But there is also phone hours during the entire exam from the visit and forward. So I think the visit we said was 9 to 10. Yeah. But since you're in so many rooms, it might take slightly longer. So don't be alarmed if there hasn't been a visit. And if you need help after the visit, just talk to one of the people handling the exam and they will call someone so you can still ask questions. And that goes for the people in Kalmar as well, but do note that I think we said the phone hours from 10 until 1. Because it makes no sense to have phone hours when I'm walking around visiting you guys here in Växjö. So that means that if you have a question and if you're on remote, you will need to stay at least until 10 o'clock to get that question answered. And here in Växjö, you just wait until someone comes. And that is, of course, assuming that Ola and I are not sort of very, very ill, because then...
Quarantine.
Yes, in quarantine, because then there will be no visit, but there will still be phone support.
Yeah.
So, yeah.
Is there a chance that exam will get cancelled? It's like 100% it's not going to.
There's not a chance, but there is risk.
Yes, yes. It depends on how you view it. But yes, there is of course a risk, but I would be very surprised if it's cancelled. Because you said you had an exam today. Yeah. And I know that there are exams planned, so I don't know if any of you are in the server administration, but there the exam is planned for Thursday. And I have not heard anything, but there is of course a risk. So if a lot of students would start to be ill, or we will find cases of the virus then who knows what they do.
Or if they close down.
Yes.
Yeah.
But you would hope that they would know today if they plan to close down on Friday. But if it's cancelled, then it's cancelled, and then we need to figure out what to do. And I mean, all of you are here, but if you feel ill on Friday, stay at home, don't go to the exam. I don't know how harsh they are. They said that they would kick out people who are sneezing and coughing, but you never know if they do that or not. But I don't know if Ola agrees, but I mean, if needed and if things happen, I am at least open to holding a 4th exam sometime. So if a lot of people miss out and you feel that you need an additional, because I mean, we can always say there's a re-exam in 3 or 4 weeks, but who knows what will happen by then? Who knows what will happen to the exam in August? But we will, I mean, it's better to stay at home, miss the exam, and hope that there will be another one, because we will do our best to make sure that everyone gets a fair opportunity. Yeah. Any other questions? No. Yeah.
Good luck.
Yes.